Okay, this is a video on the instructions for the virtual lab, which is waves on a string. On the pre-lecture questions, you're just going to answer those based on the information that you've learned so far about waves. And it has an introduction, and the actual waves on a string virtual lab will be a link in the assignments that you can go to, so you won't have to go through the website here. As some pre-lab questions, it wants you to write the definitions of a transverse wave and a longitudinal wave. And then there's some terms to define. You can use the internet for the definitions, or you can go back and look in your notes. Most of these definitions will be in there. And then you're going to draw an example of a transverse wave and label its parts. You know that a transverse wave is this kind of review. Transverse waves are like that. Those are like ocean waves. It's when the particles move perpendicular to the movement of the wave. The wave's moving this way, but the particles are moving perpendicular to the wave motion. Now, some different properties of a wave. We call it the top of a wave a crest. The bottom of a wave is called a trough. The distance between two crests or two troughs is called the wavelength. It's measured in meters. And we also have the height of a wave from the rest position, which we call amplitude. And also, another thing is frequency. Frequency is measured in hertz, and it's the amount of waves that pass through a point in 1 second. Now, some things we need to know about transverse waves is the higher the amplitude, that's the height of the wave. That means, the wave has more energy. Tsunamis have a lot more energy than just regular ocean waves. Another thing is that frequency, a high frequency wave, we had two waves, and they're like that, then this top one's going to have a higher frequency. And the reason it does, if we have, shorter wavelengths, shorter wavelengths equal higher frequency because you have more frequent waves, which equals more energy. That's why gamma rays have a lot more energy than radio waves, because they have shorter wavelengths, therefore a higher frequency and more energy. All right, you're also going to draw and label longitudinal waves. Some waves are longitudinal, like a slinky. You think about sound waves and label the different parts of that also. Then you're going to go to the virtual lab and you're going to select all these things that it tells you to. So when you go to it and you select all things, it tells you to put the amplitude at 0.75, the frequency at 1.75. You can move these or use the arrows. And when you start this, you can put it in slow motion and you'll see that the wave moves. You can always stop it, to measure the wavelength if you need to. But you can play around this and see what happens if you increase the frequency. You see the wavelengths become shorter and you have more energy. If you decrease the frequency, you're going to have longer wavelengths, therefore less energy. Now when you get to this part right here, it's asking for inverse frequency. Inverse, that is called the period of a wave. And you find the inverse frequency. So for this first one, the inverse is when you take, like if you have 0.5, you take 1 divided by 0.5, and that would be this answer. The next one, 1 divided by 1.0, would be here. Next one, 1 divided by 1.5, that would be here. So that's how you would do that column there. That's the period of your wave. Now, we also want to calculate speed, and we have an equation here. And our equation for that, and we'll be talking more about this next week, looks like this. The velocity of a wave, or wave speed, is equal to that lambda, that letter right there, stands for wavelength. And it's in should be in meters times your frequency. So you'll take this column, you'll multiply it by this column to get your wave speed. Now we have to find our wavelengths at these different frequencies. So if I go back to the virtual lab and I set my frequency, my first frequency at 0.5, use my arrows, I need to measure the wavelength. What I want to do is get this first one up here where it first starts at 0. I want to get it right there. That's going to be the first crest, and I need to measure it crest to crest. But if you notice, this goes to about 7 centimeters. So it starts from 0, goes to about 7, but it's still not a crest yet. It looked like it would be about 8 centimeters, but we got to change that to meters. How do I go centimeters to meters? I multiply by, I would divide by 100. So I'll help you with the first couple. The first one we're going to say at 0.5, we're kind of guessing the wavelength went from 0 to 8 centimeters. So that's going to be 0.8 or 0.08. Meters. So we divide our centimeters by 100, would give us the amount in meters. So if I look back next, my frequency, set my frequency to 1.0. And I'm going to play this again, and I want to stop it when it gets to 0 right there, to where that first green thing, my first crest there, is at 0 centimeters. And I want to go to, I measure to where the other crest is, and where that green one is right there at about 5. Is going to be about the same point where that is, where it is starting at 0, makes it easy measurement. So I'm going to say this is 5 centimeters between crests, and so that would be 5 divided by 100 would give you 0.05. The next measurement is 1.5. So I change my frequency to 1.5. I'll play this again. I want to stop it right there to where my green one there is at about 0 centimeters, and then the same part of the wave is going to be right around 3 point, and those increments in between 3 and 4 is like 3.2, 3.4, 3.6, 3.8, and then 4. So I'm going to say that same part of the wave there is going to be about 3.2. So it's going to be 0 to 3.2 centimeters. So that if I take 3.2 centimeters divided by 100, I would get 0.32 for my wavelength. And then I'll do one more to show you. Next frequency, I move up to 2. And I play it. I stop it when my, right there when I measure for my wavelength, that's from about 0. The same part of the wave is going to be hitting at about a little bit before 2. It's going to be about 2.8. So that'll be 2.8 centimeters divided by 100. That'll give me 0.28. So that would be 0.28 centimeters. And then you go to the next one, set it at 2.5. And again, measure it up to about right there, looking at where the green is till the next green crest is about 2.5 to 2.6. So divide that by 100. That'd be your next measurement wavelength. Then when you come back, you're going to take your frequency column and multiply it by your wavelength. So my first one would be 0.5 times 0.08. And that's going to go in this column right here, my speed. I just take my frequency times my wavelength. My next one would be 1.0 times 0.05. And that would go right here. And then so forth until you finish. And then you're going to answer these questions, number 1, number 2. And then you can omit number 3. You don't have to do that one there. Anyway, we'll be talking about wave speed more next week. Looks like next week, towards the end of the week, we'll have a test on wave properties, different types of waves, the electromagnetic spectrum, and wave speed, and also calculating something called the period of a wave. And once you're finished with that, we're going to do the post-lab activity. We watch this video and then answer this question right here. And that'll finish up this virtual lab.